Hi, everyone. My name's Daniel Moyer. I'm from Briggs Stratton Energy Solutions, and today I'm with Nathan from EG4. Hello, Nathan.
Hey Dan, how are you, buddy?
Good. How are you?
Oh man, just living it up in beautiful southern Arizona where the weather's nice.
Yeah. I'm out here in California. But speaking about where we are, I just, it's a good opportunity to mention that we also have salespeople all around the country. So welcome everybody, wherever you may be in the country, and just know that we have people in your regions as well to help. Today, we're going to be talking about combining a simplified 6.6 battery with an EG4 inverter. We'll talk a little bit about combining them with the EG4 18K PV and 12K PV, your hybrid inverter, Nathan.
Yes, sir.
But we'll also kind of dive a little bit more into the FlexBoss GridBoss combination, which you see on the right-hand side. Keep in mind that this webinar is being recorded. Everybody will get a copy of the recording and a copy of the slide decks. The chat is disabled, but the Q&A is open. So if you got any questions or comments during the presentation, Nathan and I will be keeping an eye on that. Please pop them in there and we'll go from there. Nathan, would you please give us just kind of an introduction of EG4 and what you guys are all about?
Yeah, absolutely. So those of you guys that are not familiar, EG4 basically stands for Energy Generation for Everyone. And kind of our new market strategy, effective last year, was true whole home backup, which is what we'll talk about in a little bit with the FlexBoss GridBoss combination. We were founded by Mr. James Showalter. You can see down there in the bottom picture on the right. He was named the Entrepreneur of the Year in 2025. He started EG4 back in 2020. We are based out of Sulphur Springs, Texas, about 90 miles east of Dallas Fort Worth Metro. And we are US based design, engineering, and customer support. So all the people that you call and talk to are all living here in the US. Most of us live in Texas. Like I mentioned, I do live in Arizona, but I spend a fair amount of time at our corporate facility. We do make inverters. We have our Grid Boss or our MID. We also make hybrid solar mini splits. So if you're looking to do climate control, maybe in a garage, a small shed, a mother-in-law house, things like that, we can also offer that. We offer our ground mount racking, conduit boxes, charge controllers, all proprietary stuff. And our company was built on the simple belief that homeowners deserve reliable, high performance energy system without the hassle and high price tags that you see with your traditional, big three solar manufacturers.
Yeah, you kind of mentioned a little bit there about the mini splits. Those are pretty impressive. So if anybody hasn't seen these, essentially you can take solar and put the solar directly into the outdoor unit of a mini split heat pump, right? A heat pump moves heat from one place to the other. It can heat a room, it can cool a room. You don't need an interconnection policy when you're doing that. It's pretty incredible piece of equipment. That's not what we're here to talk about today, though. But yeah, Nathan, I know you guys have just come out with a new, larger model as well. Is that right?
That's correct. Yeah, we've got a new one coming out that's actually multi-zone. So you can actually heat or cool multiple areas of a single residence or single structure without adding additional outdoor compressor heat pump units. That's correct.
Yeah, pretty incredible. So thank you. And also you said something, Nathan, that you're an American company. Well, I think it's about time that Briggs and Stratton and EG4, both American companies, came together. We have been around for over a century. We're headquartered up in Milwaukee. And the idea is that Briggs and Stratton can bring a lot of resources from engineering, tech support, sales support, but also our name. Briggs and Stratton is a well-known household name. You might remember us from lawnmowers. I know I did. Nathan, I don't know if you ever mowed the lawn
I,
back in
I
the
did,
80s.
yeah. I grew up in the Midwest, man. I had about 100 acres of property to go through and mow the lawn, and Briggs and Stratton was definitely what we utilized for the engines of all of our lawnmowers.
And yeah, and I remember when I found out that I'd be working for Briggs and Stratton, I thought back to that time I was mowing the lawn, coming out to Milwaukee for the first time, and in the distance, I see this giant water tower with Briggs and Stratton on it, next to our factory, and I was just so kind of honored to be following in the legacy of so many people before me who have helped this company grow. Both EG4, Briggs and Stratton, right, are companies that are established, that have been around, that are going to be here to honor that warranty when the time comes if you do need help. There's the picture of that water tower. If anybody ever wants to come out and take a tour, let me know. I can arrange that. So As I said at the beginning, we're going to focus a lot on the FlexBoss Grid Boss, but let's talk a little bit about the 18K PV and 12K PV, right? This is our traditional hybrid inverter. Both of them have 200 amp pass-through. Both of them have charge controllers. Both of them have the ability to do AC coupled solar generator input, the idea of a smart load output. But what I wanted to kind of mention here on this slide is that the 18K PV can do 12,000 watts from battery to load. So what we need is enough of our simplified 6.6 batteries, which you see kind of in the battery picture, in order to not have the bottleneck in the battery. And what I mean by that is if you have a full stack or three 6.6 modules in a single stack, the combined output of those three batteries is 14,000 watts. So you can put a three stack with an 18K PV and you're good to go. Now, if you only have two battery modules in a stack, the maximum output is 10.5 kilowatts out of the battery. Well, you can see with the 12K PV, that's 8,000 watts from load to battery. So we're okay. We're not having the bottleneck in the battery. And you can see I also called it out for the 21 and the 18 as well. The other thing to keep in mind, though, too, is that these batteries and the inverters also have the ability to surge. So, yes, that's the continuous output. But if we do have inductive loads like motors inside the home, we can still start those up for 10 seconds, 5 seconds, 1 second, and then drop it back down to the ability for that running current right there. Anything to add, Nathan, about the amount of PV these things can take in?
I mean, you pretty much killed it. So like with the 18K PV, top of my head, I believe that's good for up to 21 kilowatts of DC solar input. Same thing on the 12K, right? You get into the 12K, it's actually good for, I believe it's 15 or 16 kilowatts of DC input. And what that allows you to do is to maintain that continuous output while also maintaining some of that PV or DC current to maintain battery state of charge. So you're that way you're getting the full output capacity of the inverter while also still being able to charge a battery bank as well.
Yeah, yeah, great point. Now I put 12K PV. That may be like totally usable, but you can put a little bit more on it, and just
Exactly.
get a little bit inverter clipping, which is totally acceptable because you get more production in the morning and the afternoon.
Exactly.
Again, everybody's going to get access. There's links to all of the install manuals down there at the bottom. So, one thing I've been thinking a lot more about, Nathan, is the idea that you have a battery and you have an inverter that's just battery backup. There's no solar. There's no
Mhm.
generator, and you're just simply providing that backup. A lot of outages that people experience are shorter outages. With a 18K PV and a battery, we can provide that day, even 2 days or less, if depending upon their consumption, of
Sure.
instantaneous backup. If they ever choose to participate in VPP or demand response programs, they can discharge their battery to grid and still participate in some of those programs. Of course, you could add solar that will, like Nathan said, recharge the battery, power homes loads during the day, and then we can coast on the battery at night. If we want to add AC coupled solar, sure, we have that extra gen input or the extra third port that's found on these hybrid inverters. Nathan, that with the advent of the 200 amp pass through, with
Hmm.
the advent of these powerful hybrid inverters and that third port, that's what really made these hybrid inverters very versatile and a great solution for homeowners.
Absolutely. Yeah, having the ability to retroactively go back and add battery storage via that generator port or that AC coupled feature really helped drive a lot of what we have had in growth the last couple of years. Because a lot of people do have existing solar systems, but now with higher utility rates and the constant increase in utility cost every year, adding battery storage now is a much simpler process with the ability to just AC couple to a secondary system rather than being on a proprietary system like an Enphase or Tesla system.
Yeah, and those Enphase systems, right? They have anti-islanding. They're going to shut off as soon as they see the loss of grid.
That's
The
correct.
18K PV grid forming when it's off grid can form a grid that, as far as the Enphase microinverters are concerned, sees grid. And I know, Nathan, we
Yep.
could probably spend the whole hour talking about
We
frequency
definitely could.
shifting, and how many people don't realize the system does turn off, and the people losing their net metering statuses or they don't have net metering statuses. But and it's not a drawback, it's just a limitation of an 18K PV is that you can either do AC coupled solar or a generator. You can't do both. Or
Right.
you can do a smart load port, right? That third port is only kind of be used for one. There may be fancy ways to do it, but that's where the beauty of the grid boss comes into play. So just kind of the fundamentals here is that in the previous picture, the transfer switch or the MID is built into the 18 kPV. It still has one in the flex boss, but the idea here is that now the transfer switch or the point at which we disconnect from grid is no longer in the inverter. It's in the grid boss. And the grid boss is a device where all AC in, AC out. The battery is going to be paired up with the inverter, the FlexBoss 21 or FlexBoss 18. That's where our solar comes in, DC coupled solar. That's where we're going to turn AC to DC, DC to AC. It's kind of that standalone device right there. And then all we're doing is sending AC up to our grid boss. The grid boss makes it flexible if you want to do DC coupled solar, AC coupled solar, and a generator. You can do it all simultaneously with that grid boss. And Nathan, I ran out of room on my slide, but you could also have smart load ports, or you could have multiple smart load ports. Now, Nathan, I want to ask you quickly to speak about virtual power plants and how are we positioning our products together to participate in these programs where homeowners get paid to participate, paid sometimes the installer, you guys will get paid to help fund the install initially, and then any sort of dispatches. Tell me a little bit more about the importance of VPP and how that's becoming really crucial now.
Yeah, you caught me at a little bit of a loss. VPP is definitely not my area of expertise. But what we've done at EG4 is we've actually hired a team of guys that their primary focus is VPP integration. And those of you guys that don't know what VPP is, it's basically a virtual power plant, which allows the utility in your region when you're partnered up with them to actually take that battery storage when needed and apply it to a grid where they may need additional battery or additional power out, capacity. So what you can do is if you're part of our program or part of your utilities program on a VPP, is you sign an agreement that says that they are allowed to basically take that battery storage power, utilize it, but then you get a credit or you get
Yep.
some kind of financial setback that either helps offset your utility bill or at the end of the year you get, a check for X number of dollars, depending on what type of program you're on.
And that X number of dollars can be I've seen some of them don't pay a lot. I've seen some of them pay a lot, thousands
Um,
of dollars.
Yeah, I've seen some of them. I know on the East Coast specifically, that's really where our VPP program I think is more focused currently. I've seen them as high as I think about $4,000 a year for a credit for a VPP program. And
Yeah,
with that
so
being said, right, they're not stealing or not. They're not. I don't want to use the word stealing, but they're not taking all of your battery storage, right? They're taking what they need at the designated times that they need it, but then you're still also able to run your solar as well as have that remaining battery storage to also help offset your utility cost while also helping the utility maintain its current, power output production.
and they differ a little bit around the country. Reach out to
Mhm.
Nathan or myself, and we can put you in touch with some of the experts on the Briggs and Stratton team or on the EG4 team. I don't want to put
Absolutely.
my foot in the mouth, but sometimes you can also opt out of these if you don't want to participate in every event as well. So
Yes.
interesting developments as well. So let's dive a little deeper into that FlexBoss 21. I got some specs here, but really kind of what I want to focus on is the ability for this to charge the battery using grid or using solar or AC coupled solar even, and then its ability to discharge itself to send it up to that grid boss as well. And I also see, what's pretty nice, your solar inputs, MPPT PowerPoint operating range, it's 120 volts, Nathan. A
Yeah.
lot of other companies I see are 150 or 160. What that means is that we can have less solar modules in series and still build up to that voltage in order to get that charge controller to come alive. So I really like that
It,
opportunity.
that and if you're ever in maybe a low light situation where you're not getting that full
Yeah.
sun production, or maybe you've got an array that is not directly south facing and maybe you get limited sun in the morning, having that 120 range down there on the bottom allows you to start producing solar faster rather than having to wait. Maybe you have a west facing array. You get your morning sun, but it's blocked by a lot of the roof time, or maybe you have a neighbor has a tree or something like that where you're not getting full solar production, but you may hit that 120 threshold a little bit earlier. So you start gaining PV production sooner, allowing you to power those loads and as well recharge those batteries a little faster in the mornings.
Yeah, yeah, great point, especially on a cold morning. But the flex bus only has a 90 amp pass through, right? So
Hmm.
the idea is that the 18K, 12K PV have 200 amp, right? The idea that we're going to take all of the home's energy through that box, but there's no need for a 200 amp pass through on this box. We can reduce the cost a little bit and have a 90 amp pass through because we're almost always going to be pairing it up with a grid boss.
That's right.
And there's a lot on this screen, everybody. Sorry, Nathan, but I just quickly want to run through it. We'll start on the right-hand side, right? 90 amps a grid in, 90 amps a load back out. And normally this is just going to be connected up to the grid box, just one set of conductors here.
Yes.
Neutral, ground, battery breaker, dual battery inputs. I like that feature because if we have two stacks of our simplified 6.6 battery, we don't need a battery combiner. We can feed them up into both of those battery inputs, making it easier. PV charge controller is there with the ability to parallel up some strings, and then the comms board. And we won't run through a lot of those. Just know that pins L are the dry contact for the generator start. A two
Yes,
wire
sir.
signal to start, which can start up our Briggs Stratton generators as well. But you also have the Tigo transmitter built in there.
That's correct. Yeah, that was another partnership that we announced last year, along with our Briggs and Stratton partnership. So we are installing that Tigo RSS transmitter in all of our hybrid inverters in the factory. So if you're just looking for rapid shutdown compliance, it's basically plug and play. So you'll put the Tigo power optimizers on the roof, take your DC strings directly into the inverter, and you will be RSD compliant for NEC code.
Yeah, and if I believe those will work with Tigo F
That's
for the
correct. Yeah,
rapid
the
shutdown. But if you can do
yes.
optimizers or the O's or the A's, I believe you would need the tap in the CCA as well. But
That's correct. Yeah, if you're using the TS4 AOs, the MOs, and I think the SOs, all would require the tap and CCA boxes. This would only be compliant with the Type F or the Fire RSD
yeah,
compliant versions.
which in most people, if they don't have a lot of shading, they don't really need optimization. If they don't, we don't really need to look at panel module level monitoring. We don't need it. You got it here. It's not just built in, but it's one less thing you have to install as well. So I really like that. Good job, guys.
Thank you.
So yeah, we'll look at the grid boss a little bit. Again, this is kind of all AC in, AC out. There's no DC coming to this thing right here. One thing I do call out is that you have 125 amp generator port, which is pretty cool.
Yep.
That's 125 times 240 is 30,000 watts of generator power.
That's
Uh,
right. We can support up to a 30 kilowatt generator in that generator port in the grid boss. Now, when you get into 30 kilowatt, that's a massive generator. Traditionally, I see most people hovering around the like 22 to 25 kilowatts, which is 100% acceptable, especially for most homes. Most homes can be run off of a generator that size.
Yeah, and our largest air-cooled generator that Briggs & Stratton makes is 26. We also have a 22, 18, and 13 as well. And if you do end up putting a smaller generator, it doesn't have to be 30,000 like you said, Nathan. We can program the EG4 system to not overload that generator. So you can, if you got something existing that's not that big, we can still add it, and we'll just run through some of the programming to make sure we get that programmed correctly so we don't overload the generator as well.
Yes, sir.
Well, let's take a look. We're looking at a little bit more of the hardware here. So on the right-hand side, we have our service-rated entrance disconnect coming in. We got our generator port number 12. I'm going to share a little bit more about it, but you guys have a manual bypass built in. So if for whatever reason you have to service the system, or if the energy storage system goes down, we don't have to put a big clunk clunk. We can put in this, and
Mhm.
the bypass is built into it, and you have
That's right.
a little interlock, breaker interlock built into that. We can bring in 3 hybrid inverters, and we have 4 smart ports up top. So we'll dive into that a little bit deeper here in a second. But one thing I really like also is the idea that these FlexBoss, I believe, are, and I hope I don't get this wrong, NEMA 4X. So it's not just NEMA 4, but you have like one level above the standard kind of outdoor rating. And if you
Hmm.
look at the back one of these flex bosses, is that there's vent fans, but that just simply blows across a heat sink. There's nothing going inside the inverter. It's
That's
totally
correct.
sealed.
Yes, sir.
So if you're gonna have a flex boss, make sure you leave a little clearance on the sides and the top. 18 kPV, you need some on the bottom. But the grid boss, you also do need a little bit of air clearance. And keep in mind, this doesn't also include any sort of NEC clearances for working. But that grid boss, right? If I remember right, you have knockouts out the back. Is that right?
There is some, yes, but mostly on the bottom and sides.
Yep. And what I like about the flex boss is because you don't need any clearance on the bottom. You can put that right on top of a wiring gutter or a
Absolutely.
trough.
Yes, sir.
Makes it really clean installs. I really like that as well. Now the Flex Boss doesn't come with a screen. The 18 kPV and the 12 kPV have a screen by default, but you guys sell an optional screen?
Yes, we do. Yep, and it's very, very simple for the installation. It comes with a mounting bracket to actually mount that screen to the inside of the wiring cabinet, and then it basically just connects to the communication board via just a ribbon cable. So very, very simple installation. And then you would probably need to do a firmware update, as we do LCD firmware updates pretty regularly. But yeah, it's basically plug and play, and anybody can do it.
Now I'm kind of an old school person. I mean, Nathan, I remember like my Xantrax and my Schneider and my Morning Stars. We had screen because we didn't have apps. And
Yeah.
sometimes I like, and sometimes certain homeowners do, to still be able to have a screen. So I thought that was really cool that you add this optional piece of equipment. Another
Yeah.
thing is that a lot of these systems are outside or in an outbuilding where it's really hard to get to Wi-Fi. And yeah, you could put in the little Zigbee extenders and trying to make some sort of network work. But sometimes the best route is just to simply run Ethernet cable out there and hardwire the thing so you're
Yep.
not trying to get this weak Wi-Fi signal. So you have your adapter right there.
Yeah, and that's basically just a local area network adapter, plug and play with traditional Cat5 or better data cables, and yeah, just plug it into the dongle there, and then plug it into your Wi-Fi router, and you will be up and running in no time.
Thank you. So 18 kPV. Let's go back to that a little bit. This is our traditional hybrid inverter setup. We have the 18 kPV in the middle. We got our simplified 6.6 battery. Maybe we have DC coupled solar, but we got grid. We go into a meter. We go into a load center, the main load center, and then we can have backed up loads. Now, this may be a little bit different where coming right out of that meter, we go straight into the 18 kPV and we go right into that main load center. So we don't necessarily need to have that entire system built in, but it's still possible, right, to put in CTs and we can do time of use, right, to send power back up on that side. Is that right, Nathan?
Absolutely, yes, sir.
You warranty for off grid, right? We can have an off grid system on the right hand side.
Yep.
Um, we also have now talk a little bit about why we might have a flex boss without a grid boss. I'm thinking of the one on the right. Hold on one second. I'm sorry.
Yeah, no problem. So just kind of a quick overview, right? So you can use any one of our hybrid inverters in a standalone scenario, where you don't need to utilize the grid boss. A scenario where you would use that, maybe if you have no plans of future expansion, you have no plans of ever adding a generator, or you're not worried about the smart load functionality, where you're really just looking at maybe peak demand charges where you're trying to offset that. You're trying to do utility arbitrage where you're basically just zeroing out your utility cost. This is a great option, just to go in a standalone unit, and then again with batteries, with that critical loads or that backed up loads panel, that gives you the opportunity to have battery or storage during a potential outage, to help you maintain that food storage, life-saving devices, your climate control, things like that. So it's just a nice option if you have no future plans on expandability.
Yeah, and the off grid as well, right? The idea
Hmm.
is that we don't need 200 amp pass through if we're off grid because we don't have 200 amps. We don't have
That's
grid.
right.
We're just
Yeah,
simply
you're
going to add this. This is a great low cost way to do this. FlexBoss battery, solar, and a generator, right? Give you that person that off grid resilience. Now, and we're looking a little bit more at the FlexBoss GridBoss combination. So we still have that opportunity to have batteries, multiple battery stacks. Remember, you have that dual battery input.
Mhm.
We have backed up loads, non-backed up loads, which is built in, smart loads, AC coupled solar, generator. I mean, it's really exciting to see this gateway first architecture as well. And then on the right, we're showing multiple inverters coming in. And I'll talk a little bit about why that's really important because it saves a lot of conduit, a lot of combining boxes when you start to get into the larger system on the right-hand side as well. And here's the example. So, we also we're showing a solar, and if you were to think about it, though, this would be how you would do an 18K EG4 inverter as well. So, if we did an 18K PV, two of them, this is what we would have to do. We have grid, come into a meter. We have to have a disconnect. That's a box. Then we have to combine all of the grid power into a load center and then feed that into both of the grid ports on both of the inverters. Coming out of the inverters, out of the load port, we have to combine all of the load output into a load center before we send it down to our main load center. If we have a generator, the generator just has, L1, L2, neutral ground. We have to combine that into a load center and then feed that up into both of the gen ports. We have multiple batteries. We have to combine those together in a DC combiner. If it was just one, that's fine. We could combine it here, but now we're having to split it up to both inverters. Finally, if we wanted a bypass, it looks like a transfer switch, but it's really a bypass switch. That's an extra box. That's where the grid boss comes in. The generator doesn't need to be combined because it does need to be, but it's being combined inside the grid boss. The grid in and out is being combined in the grid boss. Our multiple inverter stacks are being combined in the grid boss. You guys put in a manual bypass. And we have multiple smart load ports available, all on individual relays that can open and close based on certain conditions as well. So that's the power of this grid boss is being able to combine it all into one box. Anything to add, Nathan?
No, I think you killed it. No, it really is. This is kind of the all-in-one solution to really help reduce your switchgear, as well as your overall cost for a solar installation. You can get away from a lot of those fuse disconnects. You can get away from those manual transfer switches. You can get away from those multi-combiner boxes like you were just speaking about, and kind of have that consolidation all in one place while reducing cost as well as equipment on the wall, which
Yep.
is a big one for me, right? I don't want to see 35 boxes on the side of my house, just
No.
to have a solar system and battery backup when I could put one box on the wall like the grid boss and be self-sufficient with just that one.
Yeah, especially with a bunch of stickers from PV labels that are in red too on every single box. But if you're just doing a simple system, an 18K PV and a simplified 6.6 battery may be the right choice. You don't have a generator. You don't really need smart load ports. You can keep it simple, but when we start talking about multiple inverters or multiple things that we're trying to do, like generator and AC coupled solar, that's where the grid boss shines as well. You just said it, Nathan, that
Mhm.
homeowners care about looks. And I really think the simplified 6.6 battery, along with the EG4 inverter, looks good. And a homeowner has to stare at this thing for the next 15, 20 years. So having it look good, I think is really nice. But also as us for installers, having it click together easily is really important. So every simplified 6.6 battery system is going to need the following components. You're absolutely going to need an inverter, and that's just kind of a generic inverter picture, but that could be your 18K PV or
Sure.
a FlexBoss Grid Boss. The battery stack. Each stack can have up to 3 battery modules in a stack. You do have to have a base. We have a universal floor base or wall base, and you have to have a controller on top. The controller is what kind of combines all of the DC inputs and outputs. It's also where the communication goes from the BMS, battery management system communication, over CAN bus that will go into the inverter as well. We do have another part. It's called Energy Track, and it's an optional part. And I'll talk about that here in a second. We do highly recommend it. Before I do, though, I want to just mention our warranty. So we have a 15-year warranty on the Simplified 6.6. It's unlimited cycles at 100% depth of discharge and no throughput. It's one of the most powerful warranties in the market. And I think, Nathan, what really makes it powerful is that we're not just a startup company that might go out of business and change our name in 2 years.
Sure.
Briggs Stratton's
Yeah.
been around for centuries, so we're going to be here to support you guys when you're doing this install, if anything does happen. Indoor, outdoor rated. I really like the wall base. I think it looks really clean. And Nathan, you can tell these are marketing photos. How I can tell is that this we have a 2-inch knockout. This does not look like 2-inch conduit right here.
That's definitely not.
I don't see any PV label stickers. I don't see, unless they punched into the back everywhere. I don't see any other conduit, but it looks nice. So a little bit more on Energy Track. So absolutely, and we're going to talk more about it, but EG4 has their own monitoring portal. It tells you a lot. It tells you the state of charge of the battery, how much solar is producing, status of the grid, what the loads are consuming, generators running, what that's producing. But we also have another device that's kind of separate. We call it Energy Track. What this allows us to do is to add that extra level of visibility on our batteries. Yes, there is a lot of communication between the batteries and the inverter. This allows us to really dive into the batteries, so it helps with tech support. It also allows us to update firmware on our batteries as well. But another opportunity is that there's a lot of hardware built into this device that's not being leveraged right now in anticipation of more future VPP programs, demand response, and other opportunities where communication software is really going to be the foundation of the future of our electrical grid. You could also use it as a service tool. Keep in mind that a lot of the VPP programs also already operate through the EG4 app, so you don't necessarily need this to participate. It's just that extra level of tech, right? Nathan, you get some homeowners that are just really techy, that want to see everything
all the time.
and usually those are the people that have firewalls on their home routers that's just a pain in the butt.
It can be to get communication done with people that have those type of internet restrictions. So sometimes it can be a little bit of a conversation to get them to allow us access just to get the system operational. But yeah, once you get past that firewall, it's pretty nice.
If you are going to do Energy Track, the communication from the 18K PV or the FlexBoss Grid Boss is going to go into Energy Track. Out of Energy Track, it's going to go into the battery. If you don't choose to install Energy Track, we're going to come out of the battery, out of the CAN port, and go directly into the 18K PV. You got to use this little crossover dongle because the CAN high and low are switched around, but we make it easy. Don't have to be network experts. And what I'm showing you here is that if you do have multiple batteries, you got to kind of daisy chain them together as illustrated and put a terminating resistor in the last port. If you didn't have 2 batteries, you just put that orange plug here in this RS485 port. So, Nathan, I thought it would be interesting. We get some common questions about EG4 inverters, and although some people on the call may not think to ask them, it might be interesting just to pose them and educate everyone. So, all of these systems need emergency shutdown buttons or rapid shutdown buttons.
Mm-hmm.
And a lot of times those are little extra mushroom buttons that we have to install separately.
Yes.
And that's built in, right?
It
To the
it
systems.
is. Yeah. So all of our hybrid inverters do have RSD push buttons pre-installed, including the grid boss that also actually has one as well. The limiting factor there is actually your utilities or your jurisdiction, your AHJs. Some AHJs do require that push button to be separate from the inverter and also readily accessible. Maybe if your
Yeah.
equipment is located in a garage, behind a fence or a wall. The fire department and your local jurisdictions want that push button to be readily accessible for emergency services and first responders. So, in the event that your equipment is located in a place that it's not readily accessible, you would have to add an additional e-stop or push button emergency disconnect. Like I said, in a readily accessible place. But our system is NEC compliant with rapid shutdown out of the box, as long as it's mounted in a location that's sufficient for your utility or your jurisdiction.
Yeah, and I imagine most utilities or your most inspectors are going to want this external button, which is easy to do, as shown in the middle there.
Yep,
And then what's cool though is we only have to install that on the grid boss, right? There, and then the 18K, 12K PV, those will all be controlled by one button.
that's correct. Yep. Because they're all in closed loop communication. So that is when you shut one down, the rest of the system will then go into RSD as well.
And then also cut power to that Tigo transmitter, which is then going to cut the keep alive signal going up to those Tigo Fs up on the
That's
roof.
that's
So we're
correct.
shutting down the panel as well. So
That's right. It'll actually turn off all the breakers in the batteries, so you'll actually have DC disconnect as well. So your batteries will shut down, the inverters will stop exporting power, as well as disconnecting the Tigos on the roof to keep everybody safe for
yeah,
any first responders on scene.
yeah, because if the first responders simply just kill power, they just hit a main breaker. As far as the grid boss or the flex boss or the 18K PV is concerned, it's just another grid outage, and they'll just start running on batteries. So that's why
That's
we
right.
need that. Um, this is pretty cool. So the grid boss doesn't come, well, I think some of the SKUs can be different, but there's the grid boss doesn't normally come with breakers. And it never comes with the service rated breaker, but it's
Mhm.
cool that you have the ability to do a service rated disconnect in the grid boss. I also imagine that most people already have that on the home. But do you still see situations where people are using this?
We do mostly in off-grid scenarios where people want to have a secondary form of disconnect, just solely to the fact that most jurisdictions still require a fuse disconnect or a form of disconnect between the meter or main service panel and the grid boss. So most grid-tied systems traditionally do not utilize this feature of the service entrance rated. But in an off-grid scenario where people are doing larger systems, multiple inverters, generators, AC coupled systems, mother-in-law houses, pole barns, things like that, the grid boss does inherently utilize this breaker feature. And you're right, all of our new grid bosses do not come with any breakers in them. Excuse me. But we do offer a breaker kit that can be purchased.
And what I mean by the breakers, I'm talking about the breakers over here. Nathan and I, we're talking about the smart load ports
Hmm.
and also these hybrid inverter ports, right? Because if
That's correct.
you might not use them all, you might not have three inverters, so that's great. Sell people what they need, not give them stuff they don't need.
That's right, and that's exactly why we did that. In the initial couple of versions of the Grid Boss, we were providing breakers, and ultimately, a lot of the sites that myself and other members of the technical account management team have gone out, and most of those breakers weren't being utilized. So rather than giving people things that they didn't need and keeping the cost high, we were able to remove those breakers, lower the cost a little bit, and then allow them to buy only the breakers that they need for their particular application.
And these are just standard Eaton breakers. You can get them
Yep,
down
yep,
at the
Eaton VR
local
series breakers. That's
electrical
right.
supply store. Pretty easy. If you are going to, though, use the service rated disconnect, remember we only want one point in the home where the neutral and the ground are bonded together. So pay attention to that and read through the instruction manual to understand how to bond or unbond the neutral ground as well. So, we talked about the generator port, we talked about the grid input, manual bypass a little bit, but also these smart ports. And
Mhm.
and having load control is important depending upon what NEC version of NEC you're on. You either have to size an energy storage system to supply enough power for the single largest load in the home, or you have to do the entire home in the newer versions. But if you add um, load shedding, you can kind of get around that, and that's where these smart load ports come in. Now, Nathan, I'll ask you to expand upon it, but I always, everybody always says, "Oh, these smart load ports, they're great for load shedding, right? If we're
Mhm.
off grid, solar's not producing, we don't have a generator, battery's starting to get low, let's turn off some loads so we don't drain our battery on the EV charger or
Sure.
the pool pump." I like to think of it in kind of the opposite way. So say we're off grid, no generator, but solar's producing. It's the middle of the day. The batteries are full. There's more excess solar than what's being consumed by the loads that's being clipped. Let's turn on a load. Let's turn on that EV charger. Let's turn on that water heater and then store that energy either in thermal form in a water heater or in that EV charger. So I kind of like to think of it as you know, if you got excess solar and you're off grid and the batteries are full, you're wasting it. This is an opportunity to utilize it. Anything you want to add to this, and maybe touch a little bit upon about how these smart load ports can. I talked about battery reducing, but they can do other functionality. Is that right?
Yeah, I mean, they're extremely intuitive. You've got a lot of different feature functionality, right? You can do it as an AC coupled system. All of these smart loads can be AC coupled solar, so you have that as an opportunity. And then from a smart port perspective, you have different configurations where you can do it based on the SOC of the batteries. You can do it based on the time of day you want that port to be active or deactive. So let's say it is middle of the day. It's August in Arizona, it's 120 degrees outside, the sun is cranking, your solar's good, your batteries are charged, and all your loads are managed. You could say, hey, from this time to this time, when I know the sun is going to be at its peak, I'm in peak sunlight time, all of my equipment is powered, but hey, let's turn on that pool heater, right? Let's get the water temperature up in the pool so my wife is happy. You can activate that smart port during different times of the day to ensure that you're only utilizing the excess power that you may not need, that ultimately you would be basically giving away or clipping in
Yep.
the interim if that port wasn't active. Just to kind of go on what you were talking about. But I would say mostly what we see from EG4 is people utilizing this for load management, to maintain that battery storage during an outage, or to offset cost. That's another big one, right? It is utilizing those features or turning off those larger loads during those high peak demand times. So if
Yeah.
you're on like a peak demand rate from, let's say, 4 to 9 p.m.,
And you're
let's
on grid.
right, and you're on grid, let's deactivate that port from that 4 to 9 p.m. timeline, so that way you're not drawing additional AC or utility power at that high peak demand rate.
Yeah, your water heater is still going to stay warm. It's
That's
not going
right.
to totally cool off. And it can also manually just turn off if the grid goes down too as well.
Yeah, so yeah,
Nathan,
you can leave it in that full grid forming, where the grid is present, that port is always active, or you can set it to where when the grid goes down, that port will then become deactivated to maintain that battery storage.
Nathan, I would think that it would be a pool chiller, not a pool heater if we were in New Mexico, but I could be wrong.
I mean, I'm pretty cold blooded. I like my pool temperature to be up in the high 80s, low 90s. So for me, it'd be a pool heater.
You shouldn't come to Milwaukee then in winter. Manual bypass, we talked about this already, but just kind of giving you the visual of it. So, what you could do is that if the system were down, the relays are open, and we're simply going to let power flow through here, down into here, and down to our backed up loads, and also connected here. Even if these relays were closed, right? This is open, so we're not able to have anything flowing down right here. It's a great opportunity for a backed up if we need to service the equipment or if something goes wrong, we need to work on it.
That's right. That's exactly where that ideology came from, was because ultimately, right, mechanical things break, electrical equipment fails. There's nothing that we can do as human beings to mitigate that. But what we can do is give an opportunity to maintain power to a house while servicing equipment that may have, been damaged or had a, mechanical or electrical failure. And by doing this, it basically is like adding a manual transfer switch to the side of your house, without that big additional piece of equipment. So very nice. A lot like we talked about it earlier, the aesthetics of a system. And when you start adding these big, 200 amp transformers and fuse disconnects and all of that, when you get away from that and you go to the grid boss, it's a much cleaner aesthetic, a lot less equipment on the wall, It also doesn't look horrible, right? It's a nice clean box. It gives you a lot of feature benefits like that.
Yeah, and like we mentioned earlier, there's an interlock breaker kit on this, so you can't have both of these on
Yeah,
or off at the same time as well.
that's correct.
I know we're got only a few minutes left, so I'll kind of speed it up a little bit. But controlling a generator, there's the hybrid inverters can start a generator based on a certain state of charge of the battery, right? When the battery starts to get low, we want to start a generator, which is then going to take over all the loads, AC loads, and it's also going to start to charge the battery. But EG4, Nathan, you guys made it really intuitive to also add a stop state of charge. Some of your competitors will, unless you get a little tricky with the way you program it, will just run the generator till the batteries are fully charged.
That's right.
So I think about a scenario, maybe it's evening, the sun has gone down, solar is not producing, batteries are getting low. I want to just charge the battery up, maybe to 60, 70%. I don't need a full battery because I know the next day the sun's going to come out and top off or fill up the batteries.
That's
So
right.
being able to come in here easily and adjust that, I think that's a really cool feature. It sounds simple and basic, but it's something that EG4 offers right here. One thing I'll add is our when you're using the dry contact, our generators use normally closed. So no, normally open. Sorry. So normally they're open. When they close is when the generator starts. So
Mm.
normally open is what we want to use for our system. Man, I'm gonna get in trouble from the generator guys, Nathan.
I'll call him. Don't worry.
Talk quickly, Nathan, about EMP. It's built in, right? And
Yeah,
and
yeah.
is this do people care about this kind of stuff, do you think?
Um, with EG4, kind of where we got our start in the DIY market, you have a lot of people that were really interested in that EMP hardened. Some of these individuals, I kind of fall into this category, right? Like end of the world scenario, right? Like solar flares and different, aspects of that. So EMP hardening really was driven by our DIY market, and we just basically pushed that all the way over into our grid side customers, and our new customers because EMP hardened, it doesn't necessarily have to be end of the world, right? A solar flare can have an EMP effect on electrical equipment. So to have this feature benefit is just a second safeguard to give customers a nice sense of security that their system is going to operate regardless of what the world and the sun decides to do that day.
Yeah. So, we're not here to teach how to sell systems, but when you do approach a homeowner and you're talking about what are they concerned about, what are their needs, and if this happens to come up in conversation, don't say it right away, but then save that detail to the end when you're trying to close the detail, because it's
Absolutely.
built in. I would say that our batteries are not, Nathan, just to be completely honest and clear. You would have to put the batteries in like a Faraday cage or something like
Sure.
that
And
to
and,
be able to
and
do
yeah,
that.
most other, I would say most batteries in the industry are not EMP hardened as well.
Mhm. A storm's coming in, your system knows that and can stop that time of use discharge, right? It can charge up the batteries and keep them fully charged, and you call it weather optimized function.
That's right.
I know we're running out of time, but anything to add that?
It's a great feature benefit. What I would tell you, because like you mentioned, we're running a little short on time. If you do have questions about weather optimization or any of these feature functions, generator integration, simplify batteries, reach out to myself. You can go right on our website, eg4electronics.com, request a call back. Depending on where you're located at geographically, will depend on whether it's myself or another member of our technical account management team. But we'd love to talk to you, love to explain these feature benefits and make you an EG4 customer as well as with Briggs and Stratton and the simplified batteries.
Thank you, Nathan. So as I wanted to save time for this, and this I think is really going to illustrate that added benefit to what the Grid Boss Flex Boss combination can do. So here's a house, pretty simple house, but we got our pole, a transformer, a service drop. We're going into a meter socket, meter, a disconnect, and into a load center, right? Typical. If we wanted to come in and add an energy storage system, easy. We can come in, put in an 18 kPV. We can run 200 amps into the grid port, 200 amps out of the load port, and back up the whole home. Remember, the 18 kPV is where the transfer switch is, or the MID. So if grid goes down, we disconnect from grid and we can run on energy, which we measure in kilowatt hours, to power homes' loads measured in kilowatts. Easy, right? We don't have to really add any extra cable. It's just all right here built into it. Maybe the service is on one side of the house and the load center is in the basement or on the other side of the house. Okay, no problem. We can still pop in the 18K PV there and run 200 amps in, 200 amps right back out, have our battery there, load center on the other side of the house. We can even put it down in the basement. Now, there are some NFPA 855 rules that we have to start talking about with maximum energy capacity and locations and drywall. Nathan, I'd love to have you back for that conversation. But it's easy to have it there, no problem. But now notice that another part of that NFPA 855 is that we have to have batteries that are 3 feet from doors and windows. And I don't know if you noticed, but all of a sudden the window shifted a little bit to the left. So now we don't have 3 feet to be able to put in a battery next to the service or next to the load center. So what do? Well, we can still put the inverter out there and maybe we can still have the battery in the basement, but now we're running big, thick battery cable that's carrying the 48 volt nominal. We're running DC cables all through the house at $20 a foot. It's not very practical, and also considering voltage drop considerations. Maybe we put the inverter and battery in the basement or another part of the house, and now what we have to do is take all 200 amps of the service over to that 18 kPV, and then all 200 amps of the load output back over to the load center. Because remember, transfer switch is over here. That's a lot of money in SCR 4-aught cable that you have to do. Here's the beauty of it. With the grid boss, we can put the grid boss out by the load center. That's the grid boss is where the transfer switch is now. And rather than bringing power back and forth to the inverter, with the EG4 flex boss, all we have to do is do one set of conductors in our battery, and really it has to be sized to carry 90 amps at AC, right? 2-aught or a 2 gauge. Because if grid goes out, what we're going to do is discharge the battery to send AC 90 amps over this direction into our grid boss to power the home's loads. If the grid comes back and we want to charge the battery, then we'll send 90 amps the other way and charge up the batteries. I did some quick math. Those numbers are retail and they might be a little out of date, but it shows you how this can actually save you money outside of all those other reasons that we had mentioned earlier with those extra boxes, especially if you don't need a disconnect, and especially if you have multiple inverters paired together. EG4 has a great monitoring, not just on the computer, but also on the tablet or a phone app. And there's the QR codes to get that app. So Nathan, as we're closing out, we make batteries, you make inverters. We don't want to say if somebody's having trouble, we're not going to, and you call us, we're not just going to say, oh, that's the inverter problem, go call them, right? We're going to be there to support installers no matter which way they do that. That's after the install and before the install. And one way we do that before the install is not just giving you the instruction manual, which is on the right-hand side, but also we created what's known as an integration guide that talks specifically how to program and pair a simplified 6.6 battery with an EG4 inverter. So keep that in mind. Again, these are all hyperlinked, and everybody will get a copy of this slide deck as well. Nathan, I'd ask you to kind of give us some final thoughts here, right? With Briggs Stratton, EG4, right, we have the ability to do both AC-DC coupled solar. We can bring in a generator. We can scale batteries and inverters separately. We offer off-grid and the option for the short lead times and the tech support. So kind of give me your thoughts. Why would somebody want to do, and we'll be honest to everyone, why would somebody do this option over maybe a Tesla, Enphase, or a Franklin?
Well, from an EG4 perspective, it's modularity, and that's something that I really love about EG4 is the ability to grow your system as you can. A lot of us are not financially in a place where we could go drop $100,000 on a large scale solar system with batteries and inverters and a generator and all of these things. But what EG4 allows us to do, especially with the grid boss integration, is to slowly build a system. So you can start with a very simple, couple of batteries, one inverter, one grid boss. And then as you can financially afford it or as demand, dictates, you can then grow that system with additional battery storage, adding a second or third inverter, also getting rid of some of those loads, utilizing the smart port functionality. I would say in today's market, with constant utility increases, with these data centers coming online, with microprocessing plants coming online and using large amounts of power, VPPs are really going to come into market. And I would say if you're installing a solar system without batteries, you're doing it wrong. And it's really, I mean, it's the cold hard truth of the industry right now. I've already seen a 7% rate increase at my house here in Arizona, and we were expecting an
Mhm.
additional 12% by the end of the year. So that's going to be a 19% increase in 1 year. And that I imagine is going to continue to grow as we see those data centers and these microprocessing plants and things like that come online, as well as in the community where I live. I think they're building an additional 10,000 homes this year alone.
Wow.
So we're going to see a lot more demand on the utility. We're going to see VPPs being a lot more utilized and a lot more demand from that utility. So I would say put batteries in, benefit from those VPP programs, get that credit back from your utility, as well as having that energy storage on the backside. So if you do have an outage, you have that ability to maintain your food storage or life-saving devices and things like that.
Yeah, and I like that you led with the batteries can be a grid interactive appliance with solar that can help homeowners save money. Secondarily, but not necessarily less important, is that backup as well. And Nathan, as we kind of close out, I kind of skipped over our tech support, our customer service, but really, inverters and batteries are becoming very commoditized, and a lot of people are doing them. But I know that you guys, for installers who are authorized, have a level 2 direct support tech support phone line.
That's correct.
You get a
Yep.
code every day, a new code generated, and you can call in. Um, Same thing with here. I'm here to be a resource as well. Um, Nathan, could you please pop in your email into the chat for everybody, or the Q&A, I'm sorry.
Yeah, and throw up the
Um,
Q&A.
and if this is an opportunity, anybody has Q&A, please go ahead and add that right now. But again, Nathan and I are here to be that first line to help everybody out. Lastly, everybody will get a copy of the recording and also the slide deck as well. Thank you, Nathan.
That is in the chat.
Let me pop it into the Q&A really quick.
I'm not a Zoom guy, Dan. I was trying to
Okay.
figure out how to do
Well, what
it.
I'll do, everybody, we will go ahead and put Nathan's email into the email that goes out with everybody.
Yeah, please.
I'm Daniel Moyer from Briggs Stratton. Nathan, thank you so much for joining us,
Absolutely, Dan. Thanks for having me.
and we'll see everybody next time as well. All right.
Thank you.
Take care.